Today's lesson is about applying both vertical and horizontal stretches and compressions to our sine and cosine graph. So last lesson, there we go. We focused on what does this graph look like if I'm graphing sine. Okay, so the amplitude was 1. Period was 360 degrees. And if you remember, for sine, we'll go middle, high, middle, low, middle. Cosine is high, middle, low, middle, high. One of them starts in the middle and it goes up. The other one starts high and it goes down. So, things I like to throw on here because I'm a colorful person. Amp line, because these are the base graphs, our amp line happens along, or it's the equation of the axis, happens along the x-axis. Then I'm going to throw my points on here. Origin, middle, up to 1, high, 180, middle, 270, low, 360, middle. So our sine. Oh, so close. I was doing so well. Like right here. I lost it right there. I was trying to be extra quiet so I could focus. Ta-da! I did a really nice one! Okay. And then we'll go cos. High, 90, middle, low, middle, high. So this is like the sine curve, it's just a different part of it. Like if we were to continue going up, see how it's all the same thing. That's funny actually. It wasn't supposed to make that connection, but focus. Nope, I'm not overly happy with that one, but it is what it is. Okay, and for cos as well, our base graph has an amp of 1 and a period of 360. Okay, so sine, middle, high, middle, low, middle, cos, high, middle, low, middle, high, amplitude of 1. Let's start fiddling with things. We're going to first do an example of sine, and this is all the same sine graph, except we are going to apply vertical stretches, compressions, reflections. We're changing the amp. So for all of the other functions that we've been working on, we've referred to those as vertical stretch or compressions. With trig functions, because trig just wants to be a little bit different and weird, we just say the amplitude changes. Okay, there's a different amplitude. So let's do some colorage. This one is blue. Middle, high, middle, low, middle. So we go up to 1, we go down to 1. Okay. Then let's look at what happens here. What's our amplitude now? This is an amp of 2. So our pattern stays middle, but instead of going up to 1 here on our high, we're going to go up to 2. And then we go back to middle, and then instead of going low to a -1, we're going to go low to a -2 because our amplitude gets doubled. Okay, and then we're back to middle. The y value of the middle term is 0, so even if you were to try and apply math to that, it doesn't do anything because when you multiply it by 0, it's going to stay the same. High. Oh God. Ta-da! Okay, third one. Here, this is a vertical compression by a factor of 2 or a vertical stretch by a factor of 1/2. Okay, so we're dividing our amplitude by 2. We're halving it because it's 1/2. So here, our amp is going to be 0.5 or 1/2. So instead of, we start at the middle, but then instead of going up to 1, our amp is only going to go up to a half. Then we go middle, and then our low, instead of going down to -1, it's going to only go down a half. Middle. So middle, high, middle. Oh, we're redoing it. It was good at the beginning. Middle, flip-a-jibbit. Middle, high, middle, low, middle. Okay, third time's the charm. Blah, 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 blah. Don't like that. Okay. Now, with the fourth example, we've got a situation where we have a reflection. So instead of our pattern being middle, high, middle, low, middle, how do I want to do this? Middle, high, middle, low, middle. These are going to change. And it's going to become middle, low, middle, high, middle. Because we've got a reflection happening. The middle stay the same. But instead of going up, we're going to go down to start. Now, it's a -1, so our amplitude is 1. Oops-a-daisies, I want that in purple. Amp is 1. So we'll go middle. Instead of going 90 high, we're going to go 90 low, 180 middle, 270 high, 360 middle. Okay, okay, okay. Okay, we got there. So that's what happens with our Y values when we've got a stretch or compression. All we're doing is changing the amplitude. Our pattern doesn't change. Okay, that's the really nice thing about trig functions. If we have the absolute value of the amplitude, this is just saying, like, for this one and this one, we're just assuming positive numbers. This one takes into account the negative. So if you've got an a value in front of the function that is larger than 1, the graph will be vertically stretched by a factor of a. If you've got a fraction set between 0 and 1, the graph will be vertically compressed by a factor of the whole fraction. It goes against my better nature, but that's okay. And then we will, if it's a negative value in front, all you're doing is you're reflecting in the x-axis. Boom, boom.